There are generally two common types of pH meters available on the market today. The first type is the portable pen-style pH meter. In this design, the sensor and the main body are combined as a single, compact unit. Because the parts are built together, the sensor cannot be separated or replaced. This makes it very convenient to carry, but gives less flexibility for different test applications. The second type of pH meter is the separated design. In this style, the host unit and the sensor are two independent pieces. Users can choose different sensors based on their needs, such as sensors for liquids, gels, soil, or high-precision use. The sensor must be installed before measurement, but this design provides much more versatility. Today, I will be introducing TECPEL's portable pH meter, model pH-703. In our daily lives, we constantly come into contact with items that have varying pH levels. Examples include foods and beverages, the materials we touch, detergents used at home, and even the drinking water that we consume every day. Understanding pH helps us better evaluate safety, quality, and the characteristics of these everyday items. The TECPEL pH-703 is a portable pH meter with an all-in-one design. The sensor and the main body are integrated together, meaning they cannot be removed or replaced. This structure ensures a stable, durable, and easy-to-use measuring tool. Before the first use, the included battery must be installed, and the protective cap covering the sensor must be removed. Once these steps are completed, the pH meter is ready for setup and calibration. Before any accurate measurement can be performed, calibration is essential. For the first use, take out the included pH 7.0 standard buffer solution. Prepare a clean container and pour the buffer solution into it. Turn on the pH 703 and place the sensor into the solution. It is important to wait patiently until the reading on the display becomes stable. A stable value indicates that the sensing element has fully reacted with the buffer liquid. Ideally, the displayed value should be close to pH 7.0. However, you may notice slight changes depending on the surrounding temperature. The bottle of the standard buffer includes a reference table showing how temperature affects the pH value. At lower temperatures, the reading may shift slightly toward the alkaline side, while higher temperatures may cause the reading to shift slightly toward the acidic side. This is a normal chemical behavior, and the calibration process allows us to correct for this variation. If the reading does not show exactly 7.00, we can make a fine adjustment. For example, if the meter shows 6.84, we can adjust it to 7.00. Use the included small adjustment screwdriver and locate the calibration hole on the side of the meter. Insert the screwdriver gently and rotate it slowly while observing the display. When the screen shows exactly 7.00, the calibration process is complete. Now, remove the pH meter and rinse the sensor thoroughly with clean water. Once cleaned, the instrument is ready for real measurements. Let's start with a simple and common example, measuring tap water. Tap water in most households typically falls around pH 7 and is slightly alkaline. Pour about 1/3 of a clean cup of water. You don't need a large amount, just enough to immerse the sensor. Before measuring any sample, always rinse the sensor to ensure accuracy. Then place the sensor into the tap water. After a few moments, the reading will stabilize. You may see a value between pH 7.5 and 7.6, which is considered normal for household tap water. Once the reading stops fluctuating, you can record the value. Now let's test something that many people drink often: soda. Soda drinks are usually acidic. Again, pour a small amount of soda into a clean container, rinse the sensor, and place it into the soda. You will immediately notice that the reading begins to drop. A typical value for soda is around pH 2.8, showing clearly that it is an acidic beverage. This helps explain why soda can cause tooth erosion and why it tastes tangy or sour. For your convenience, here is a simple comparison concept. Slightly alkaline beverages are generally more beneficial for the body, while highly acidic drinks are less ideal. In fact, most foods in our daily diet fall on the acidic side. This does not mean they are harmful, but understanding pH helps us balance our choices. Next, let's measure a household cleaner, such as a common detergent. Pour a small amount into a clean cup. As before, rinse the sensor and place it into the detergent. Household cleaning products tend to be alkaline because alkaline substances help dissolve oils and dirt more effectively. In our demonstration, the reading shows around pH 10.49, indicating a strongly alkaline solution. It is important to remember that high alkaline liquids can irritate or burn the skin. If any cleaner gets on your skin, rinse it immediately with plenty of water. Do not use acidic liquids in an attempt to neutralize the cleaner. This can cause unexpected reactions. Plain water is always the safest and correct way to wash it away. After all measurements are complete, rinse the sensor again to keep it clean and ready for the next use. Proper cleaning ensures accurate readings and extends the life of the pH meter. With these steps, we have demonstrated the features and operation of the TECPEL pH-703 portable pH meter. Its simple design, stable performance, and practical functions make it a reliable tool for everyday pH testing.